Hey everyone, in today's video I'm going to be going over tools like Netstat, Nmap, and Nmap, and to talk about how you can use them to find out what ports are running on a host or in a network, what different services there are, what operating systems are being run, and then how you can use that information to potentially secure that network, secure those hosts, lock it down, and find out maybe some vulnerabilities along the way as well. One thing that's important to know about doing this kind of work is the ethics involved in it. When you're using a tool like Nmap, it could potentially be seen as unethical if you're not doing it with the right permissions. You only ever want to use a tool like Nmap to do scanning when it's against your own hosts, something that you have complete control over. Even a company you were working for, if you got caught using a tool without express permission for a specific purpose to be doing something like that, you could get in trouble, lose your job, or worse. So you always want to make sure that you have that permission, even working with clients in a professional scenario, express written permission to say, yes, you can use this to accomplish these set of tasks. So always remember that when using tools like this. So anyways, let's get started with Netstat, because it's sort of a simple tool, command line based on every install of Windows. So there's a lot you can do with it. Here today, I have a simple little network set up. I have a Kali Linux machine and a Windows 10 machine, and they are not connected to the internet. They're just on a subnet with each other. So when we run Netstat, what that's going to do is it's going to show us all active connections. If you ran this on your home computer right now, you'd probably see a huge list of connections. You have different things open in the background, Google Chrome with 10 different tabs because you got YouTube and Reddit and a bunch of other things open in the background, or even applications like Steam running, right? Like that's going to be creating connections. But again, because this is a host on its own, you can see under active connections, there's nothing. And if it's not already extremely apparent at this point, you should be watching this video in 1080p full screen to get the full effect, because we're looking at some small text here on a monitor. So how do we generate connections? On a host here with pretty much nothing going on. Well, you may have noticed in the background here that we got a FileZilla server running. So if I pop open this FileZilla server interface, it's going to want to connect to the local host, which is our personal computer here, using the administration port in place. So now it's trying to establish a connection. And maybe we should actually try and connect. And there we go. We see our local host address there, loopback 127.0.0.1. connected to the foreign address of our desktop, which is just some generic name of our Windows computer that was assigned. And the connection is established. And then if we go ahead and close this and we run Netstat again, we can see that that connection is now in a state of closed waiting. And over time, as we continue to check Netstat, you're going to see those connections completely close off, because they will remain open for a bit on the server. But what else can we use Netstat for? I mean, so far that's kind of pretty limited, not really showing us a lot, not really giving us anything helpful other than to say, yep, we connected to a FileZilla server. Netstat has a lot of different flags that give a lot of different information. So going back here, we can see we can use all these other parameters, -A, -B, E, F, and so on and so forth, to discover a lot of information about our host. And depending how we combine some of these together, we can start to get some pretty useful information. So, if we do Netstat -A to display all connections and listening ports. So Netstat by itself displays all connections, but when we do -A, now we get all listening ports as well. And immediately you see something that might look a lot more familiar when you run this on your own computer. Just this huge list of information here. So starting at the top, we have the address of 000, and it's listening on port 21, on port 80, 135, 445, like SMB, HTTP, Netstat, or pardon me, NetBIOS, FTP. All these different ports are active right now. And the local address here in this case, you can see there's a few different ones listed. We have 000. That pretty much means all interfaces on your computer. Like you have the loopback IP, and you have the IP address assigned on your Ethernet card or your wireless interface. So it's saying that all these addresses, all these 10s and 127s are listening on port 21. So if you tried to connect to either of those IP addresses on port 21, you would get the same result, which is connecting to the FTP server that's running. Similarly, the same goes for port 80. So let's just actually go ahead and try that out right now. So if I go to HTTP 10.0.0.1, there we get the splash page for IIS. And similarly, if we go to 127, oops, if I can type, .0.0.1, same splash page. So that gives you an idea of how to interpret some of these results. And then you see a lot of other stuff here too. These colons are these sort of the same thing as the 0, except it's just IPv6. And then again, the IPv6 loopback address of : 1. And then the other half of these scan results here, or this Netstat, are all these UDP ones listening. And because UDP is connectionless, you'll see that the foreign address is always just blank. But though this information is useful, it maybe doesn't give us the full picture or the sort of information we would need to like act on this and effectively secure a machine that was running some of these ports. Like say this was supposed to be an HTTP server, but we didn't want FTP on there. Okay, now we know that FTP is running because we see it on there. We can say, okay, we can shut that down. But what is it running? Well, using the -B flag, we can display the process that is tied with that listening port. It requires an elevated command prompt. So now if we go again and run the AB, so it's doing all along with the process. Now we see that the process tied with 21, with FTP port 21, is that FileZilla server. So again, in our scenario here, where we want to know, hey, what is running port 21? Because I need to get rid of that. I need to uninstall it or put up firewall rules or what have you. Using that -B flag gives us that information. It doesn't give us all the information all the time though. You see here, it says TCP 80 cannot obtain ownership information. Another useful flag here is the O, and it's kind of going to confirm what we already know. But -O shows the process ID here, and for this here, let's find it again. Sorry, here we go. Yeah, this TCP port 80 cannot obtain ownership information. Process ID 4. Process ID 4 is the system. So it's basically an elevated, beyond the administrative privileges that we're running this command prompt at. So it doesn't show us that. But in a lot of cases, it's going to be like these SVC hosts that you see. Like this SVC host here is, or pardon me, this SVC host is associated with RPC, but the one below that at process ID 4 here is 445, which is SMB, So now we know that SMB is running on this host, and it's running at the system level, which suggests it's over Microsoft's own SMB service. Like, it's not some other third-party tool using SMB. Because if it was, then it'd be running probably with the like administrator privileges, and we'd see the actual name of the process here as opposed to having it be blank. So yeah, using this information with Netstat is a pretty quick way to get a decent idea of what's happening on your host. And Netstat is available on Linux as well, so it's not just a Windows-only command line tool. It's on Linux as well, though some of the flags may vary. So just, use the manual on Linux and read what all those flags are, because again here, it's not too hard to understand. Like, it's pretty verbose in the explanation. So it should be pretty obvious, and you can play around with it, see what kind of different combinations you can use and how that information relays with you. But now we can move on to Nmap. Nmap gives us a lot more information, and it's a very useful tool to learn. If you're planning on working in security, learn this tool. It's very, very useful. But what we're going to do here is open some scan results. One thing about Nmap is that the scans, depending on how you run them, can take a good amount of time. And depending how many hosts you're running again, I mean, it could take hours. Like, you could easily have an Nmap scan that lasts more than a day if you're doing it against like a full network. In this case, again, I only have the Windows host and the Linux host running. So I've only scanned 2 hosts, but we'll take a look at both of them and we'll go through the results and compare. So let's start off with this first scan that I ran here. This is against 10.0.0.2. So this is my Linux host, my Kali Linux. And when we switch over to the ports, you can see that the only port it found running was 1337. And so it's open, but the service is waste, and that's not a real name of a service. We'll look at that in a minute. And then in this specific scan, we get the name of the operating system saying it's Linux version 2.4.21, and the accuracy is 100% on that. It's confident that that is in fact the operating system being used. The only other port information we get is some UDP port that is closed and another TCP port that's closed, but 1337 is open. So when you see a port like this being open, this is something that you do want to investigate. Like, this is a suspicious port being open, but it's not necessarily going to show up in all of your scan results. So let's back up here a second and look at how I actually ran this scan and what flags I used. Let's go back to sort of how we were approaching the use of Netstat, and we'll use that same logic with Nmap. So with Nmap here, you can see that the command is up at the top. You put in your target, and then you can choose a profile. And the profile, there's a bunch of different options. There's a ping scan, a quick scan plus, blah, 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 all these different ones. Slow comprehensive scan. And they're all going to give us different results for the most part. In this case, this was an intent scan, all TCP ports. So let's break this scan down here. So we're running an Nmap, and we're doing -p to specify our port range. In this case, the scan is being ran against ports 1 through 65,535. So all the ports, of course, 0 being used for ICMP, but excluded from Nmap scans. And then T4. T4 is like the amount of time that the scan is going to spend on different services, different ports, waiting for connections, waiting for timeouts. So 4 is 4 is going to be faster, starting at 0. So T0, That's like the slowest possible. It's going to wait and wait and wait for like, timeouts. And then T5 would be as fast as possible. Moving on to dash A, that is our OS detection and version detection. So as we look at different services, it's going to try to detect what version of services are being ran. And then V is verbose. So it's going to print more information about what it's discovering. So now going back, we see in the scan here, it says, oh, reset from 10.0.0.2. Is this really open? What is this port? So in a case like this, if we were going to investigate what is running on 1337 on our host here, 10.0.0.2, there's a lot of different things you can do. One useful thing that I like to do is use Telnet. Let's take a look here at using Telnet to connect to our own web server. So I'm telnetting to my own IP address on port 80. And we see that we kind of get nothing back. So let's go ahead and close that. But then we see the response back. And it's a 400 bad request. And it's saying, hey, HTTP 400 error, blah, spitting this out, connection to host lost. So you can use Telnet for more than just a Telnet connection. You can Telnet to a specific port, and it might give you some information about what's being run. So again, let's take a look at that here. Server Microsoft HTTP API 2.0. So if we didn't already know, now we know that on port 80 on this host, we're getting a Microsoft HTTP server response. So okay, now we have that information. So with that in mind, let's go take a look and see if we get anything back from our friend here at 1337, our 10.0.0.2 1337. And we aren't getting anything. So let's just type something in here and just if config. And let's take a look at what's happening over on our other host. So you can see what I was just typing there, if config, even though I kind of butchered it, is popping up here. And there's a connection. It says from 10.0.0.1 connecting to 10.0.0.2. And what we have here is a Netcat backdoor effectively. And this Netcat is listening on port 1337 for connections. And if we actually go back to our Windows host here, and let's get rid of this. New command prompt. And what we can do is netcat to our other IP address on the correct port. And we'll specify an executable to run. And that's going to be the command prompt. And I put nc in, and on Windows it's actually ncat. You get it when you install Nmap. But the target machine is refusing it. So let's go take a look back at our Kali. And because this connection is already here, we're going to have to restart it. We already interacted with it. So it's being dropped. But now that we do this, you can see it's just sort of listening, right? Like nothing is being returned back. So we'll jump back once more to our Kali host, and we can see here that we have a command prompt. We have the cmd.exe being ran across this netcat backdoor. And with that, I can run the IP config. I can see what's configured on my adapters here, the IP addresses. You can change directories and go back in here. And later, let's go make directory and users test. And if we jump back to our Windows machine, we can go to users. And oh, the access is denied. I noticed that in the background now. So it's not running it over over an admin prompt, but let's go cd back into user. I believe my user was, and let's try it here. Make directory test, and still access denied. Oh no, pardon me. I was looking at the same one. So yeah, now that because we're in our own user directory, that test directory was created. So there's a little bit of an example of what you can do and what you can find with Nmap. You can see that this port is listening. Let's investigate it and see that, oh, it ends up being a backdoor, or a potential backdoor in this case. So that's just a neat example, but let's go into something that's more practical. Going back to our scan results here, I'm going to open another one. So this is an intense scan of our same host as before, this 10.0.0.2 Kali Linux. And this time you can see with the same scan parameters, it ended up finding 22 and 80. So that's because I turned on OpenSSH and Apache too. So let's go ahead and actually try accessing those. Now that we know that those are open, that means we should be able to get to them. So this is the web server on our Kali Linux host, running on port 80. It's not running on HTTPS, because if we try that, it gets nothing. And we know that it scanned every port, but it didn't return 443. So yeah, this is a insecure web server. It's not really hosting much, but it's still useful information. If you have a web server that you end up scanning and it's only on port 80, you should probably try to flip that over to 443. It's really your best bet. And looking back at that result there, we remember we're also running SSH. So if we try to SSH over to that host, we can accept the key, try logging on as root. And I'm pretty sure I left root access disabled for SSH. Yeah, that was access denied. But still, we get that prompt back, and if I didn't forget to enable that, we could access this. So there we go, an example of two services that we discovered on a remote host and how we can interact with them. In this example of finding SSH open, it's a good example of how you could use that when you're discovering a network. If you were hired to investigate a client's network and discover vulnerabilities, you may notice services like SSH or VNC or RDP open on different hosts, and you could use that to try and access it. Maybe you find accounts that are, have default passwords on them, or not password protected at all over some RDP sessions or something like that. So again, sort of a real example there of how you can use that to discover a network and interact with it that way. Let's go take a look at another set of scan results. So the next one is a ping sweep on the topic of discovering a network. If you were to sit down in a network that you didn't know, well, one thing you can do is check your own IP address. close that. So when we run this ipconfig, we see that our IP is 10.0.0.1 and it's a /8 for the subnet mask. So something useful to do is a ping sweep here, this ping scan. And basically just see which hosts in the network are up and responding to a ping. Maybe they have their firewalls on, so that's going to disallow the ping. But this at least gives you something to start working with. So the syntax for the ping sweep is just SN and then your address or your subnet. Again, in this case, I was on a 10/8, but because I already know that I only have 2 hosts to save a bit of time on a ping scan, I just ran the /28. So it's a smaller subset of that. And if you wanted to, you could run through different subnets on that range and see what's coming back or split it up. So a simple ping sweep on a network that you're unfamiliar with at least gives you an example of what hosts are available. And now you can start targeting them more directly with more specific scanning parameters. So moving past that ping sweep, I do a scan of /28, and this is a regular scan. This is pretty quick and it's pretty useful. This will be done in like 2 seconds for these 2 hosts that I ran. And immediately it tells us, hey, you got port 21 open, you got port 80 open, and then these NetBIOS ports, and SMB. And then on our other host, it's the SSH and HTTP that we already saw. But it may not give us the sort of information we're looking regarding that. The sort of detailed information. Like this gives us an idea of where to manually start, but it doesn't feed us, anything with a little bit more juice that would help, do a more targeted scan or a more targeted attack if you were, hired to like exploit something or prove a vulnerability exists. So let's take a look at the next scan, and this is an intent scan. So the intent scan, again, so it's T4, so it's going, faster, it's more aggressive, -A. So that's going to give us that fingerprint information. It's going to identify what's being ran on the host, version information of some of these services, and V for verbose to give us some extra detail. So now if you remember on our previous scan, it didn't even show us the operating system information, right? It just showed us this service. So now we have this information of FTP, FileZilla is being ran, HTTP, it's Microsoft IIS 10.0, RPC is being ran on there, and then Windows NetBIOS. And for our SMB, it even shows Windows 10 Pro, the work group name, some pretty useful stuff there. And you look at this host details and you can see some more of that information about the versions that are being ran. Operating system, Windows 10 gives us some build information there as well. And then we take a look at the other host, our Kali Linux host, and it says, Linux.2.6.32. The accuracy is 96%. I think if you remember on one of our other scans, I'm not sure I actually have gotten into it yet, but the accuracy was 100%. And I think it was Linux 2.4.2 or something. So one thing that's missing from these scan results so far that you may remember is that same port 1337. Like we haven't seen it come back up yet, except for that full port range that we did. So let's take a look at another scan result here. So this was the intent scan without our 1337. And now this is an intent scan, all TCP ports. So we do Nmap, specify that port range, full 1 to 65535, T4, so it's fast. We get that fingerprint information, it's verbose, and we're doing it for this network segment here. Now on 1002, we see that 1337 come up again. So when you use SS or -ST in your scan parameters, that's basically looking at like the common ports. I'm gonna open this Nmap website here, and I'll link these two pages. They're both very useful. So this page here talks about some of the command line flags here, and going back to ST, which is what we were using in a lot of our scans. So this is a connect scan. It's connecting, like it's making a TCP connection to these ports. But it's not giving us the full range of ports. Again, it's just these common ports. It's not giving us all the information that we want. So yes, a full range is going to take a lot longer, but compared to the ST scan, the connect scan, you're getting a lot more out of it. So in the example of a competition, like a CTF sort of competition or a cyber defense competition, you would want to run both of them, given you have the time, at different points. Like it may be more beneficial out of the gate to run a quick scan, understand what's the basic ports that are there are, start working on getting some of those services out of the picture or securing them, and then move on over to a comprehensive scan in the background that's going to give you more information. So I'll link both of these pages in the description below the video. And you should read through a lot of these flags. Like it gives you a lot of information here that I can't discuss in this short video as I go on to minute 32 here. And yeah, it's really useful stuff. Nmap is a very powerful tool that you can do a lot with. So I believe this was my last scan result on the Windows side. Yeah, but I do have some scan results to look at on our Kali Linux system as well. Because again, Nmap, also a command line tool that we can use, not just through the Nmap GUI in Windows. So yeah, here was our Netcat stuff. But let's take a look at some of the same type of scan results in Kali. So if we just do this regular scan, Nmap 10002, we see, yep, we have SSH and HTTP open. Moving on. So here we're doing the connection scan, ST, establish a TCP handshake there, verbose. T4, it's an aggressive scan, and then A to get some of that fingerprint information. So now we take a look at our services here, and it says, oh yeah, you're running SSH, it's open SSH, Debian, and then Apache, it's giving us the version there. And it even tells us some supported methods here on the HTTP server. So quickly going back to the Windows 10 one here, I'm going to take a look, I believe, at this one, and sorry, I want to show the example of the web server, because yeah, this should be it. Yeah, here we go. When we get this extra information from our Nmap scan here, we're actually like doing some fingerprinting and printing out this verbose information. It can give you some pretty solid hints. Like with the supported methods, you can see here that by default, IIS is allowing the trace method, which Nmap is even flagging itself saying, hey, well, this is a potentially risky method, and the trace method can be used in these like cross-site tracing attacks or cross-site scripting attacks. So that alone gives you like, oh, maybe I should look at the HTTP options that I have available on my server. Like if the only thing you need to do on your server is do GET requests, then don't allow posts. Don't allow anything but GET. You know, things like head and options, though they can be useful in their own right, if they're not necessary, get rid of them. And especially trace in this method, like it's actually saying, you know, it can be used against attacks. There's ways to prevent those attacks, of course, but if you're just doing like host level fixes for this stuff, probably best to turn off. So going back here, again, we see that we get some more detailed information when we specify the parameters, but because that ST only checks the common ports, we have to go out of our way to specify the port range. And in this case, instead of doing all 65,000, I'm just doing 1 to 1338. So I'm just like making the point of, hey, when you scan for 1337, you tell it to, then it does show up. It's showing up again as that, oh, is this a waste? What is this port? And then here is the stealth scan, but I'm also specifying like, hey, let's check out these ports, and it still finds it. And then the final scan here was the stealth scan alone. I did a T5, so it's even faster. But fingerprint and get that verbose information. And then finally, you can see it only finds 22 and 80, no 1337. So that is a pretty broad overview, an intro to using Nmap, to using Netstat. I highly recommend using these tools, learning more about them, reading more about them. Now that you have a basic understanding of how to use some of these parameters on the scans, the best thing you can do is like get 2 hosts up, or if you have a network that you can do this on, something that you control and it's yours, run a scan and then change the parameters of the scan and compare the results. See how a connectionless scan versus a connecting scan gives you different information. See how, doing a TCP scan from ports 0 to 1,000 or 1 to 1,000 differs from doing 1,000 to 65,000. See what different kind of results you get, and then choose to also scan UDP one time, and the other time don't. Do a TCP only scan. There's a lot you can do with this tool. It gives you a lot of different information, so it's best to just play with it yourself and figure it out that way. Anyways, that's it for this video. Thank you for watching, and until next time, bye for now.